Hi, Sophie, Grace, and Brisa. We're here to learn more about engines, and today we talk about engine blocks, engine displacement, and the different variations of engines. So there's three main types of engines: V engines and inline engines, which I mentioned on yesterday, and a new type we'll learn about today known as flat engines. So first off, let's start with a V engine, which is probably the most common type here in the United States. A V engine, if you look at it from the top, this is like a top view of it, you'll see that the engine, there's two blocks of cylinders. So this is like the circles here. We're viewing the cylinders from the top without like cylinder heads or anything, nothing covering them up. This is what it would look like if you took it all apart. And you can't tell this by my drawing, but these would be tilted like this. So if you were looking at it from the top, you wouldn't be looking at them exactly straight. You'd be looking at them slightly tilted. And V engines, you could pack more cylinders, which is why there's V8s, V12s, V10s, and you could pack them in a smaller space because they're right next to each other and they're kind of tilted, which means you don't need as large of an engine bay in order to house these engines. But the disadvantage of them is as these cylinders are moving like this, like we talked about yesterday, it's creating a force because they're moving so fast. And of course, Newton's law of gravity, opposite actions equal opposite reactions. So when it moves, it wants to create another force, going the opposite way. So V engines actually have to have extra weight to balance it out so they don't vibrate a bunch. On the other hand, we have inline engines. This is the top view of an inline engine. And if you're looking from the top, you're looking at it perfectly straight on. The top of the engine is completely flat. And they're longer, which means which is why there's only ever inline sixes. That's about as big as they get. There's hardly anything bigger. But they balance themselves out. You don't need any extra weights. And it's usually a simpler design, so you don't need any complicated belts and shafts and stuff to help these operate better, as opposed to V engines. So now, our other type of engine, we're going to look at flat engines. So flat engines are like V engines, but with V engines, the pistons moving up and down like this, they are arranged like this. Flat engines, the pistons lay completely flat. They lay completely parallel to the ground and perpendicular to each other. And within the area of flat engines, there's also boxer engines. So this diagram right here, we're looking at it from the side. So imagine like you're standing on the side of a car. This right here is what you would look at. Like I'm standing on the side of a Porsche 911, a Subaru WRX. You could only see, if there's 4 cylinders, that means I could only see 2 of them on one side. You'd have to walk all the way around the engine to see the other 2 cylinders. So here we'll look at it from a top. This is just a regular flat engine right here. This piston goes this way, this one goes this way, and if there was more, this way, this way. Now, these engines, they do balance themselves out because they're going perpendicular. Perpendicular, I don't know, but they're going like straight on with each other. But you see with this flat engine, there's some wasted space, but that kind of helps because it kind of helps balance the forces of the engine. And this is a boxer engine, so this we're looking at it from the top. Now you see this piston moves like this, but this on this side, it moves like this, which is why it's called boxer engine, because it looks like they're punching at each other. That's how they got that name. Boxer engines, you could sit them lower to the ground, which means you could make your center of gravity lower, which could help you take off. It helps you go through turns better, but it takes up a lot of space. Your car needs to be wider a lot of times to house these engines, and you have to have 2 sets of everything: 2 sets of cams, 2 sets of rocker arms, 2 sets of everything in order to help it work. And very few people actually know how to work on these engines just because they're so weird. And also, to work on it, a lot of times you have to drop it completely out of the car as opposed to just leaving it inside the car and working on it. You have to completely take it out. So now you know the new type of engine. Let's go on to a different aspect of it. Let's look at engine blocks. So the entire unit that the engine is housed in is known as the block. So I'll draw you a little block here. So the block is the apparatus to which the cylinder sits in, but it itself actually isn't a completely solid hunk of metal. So if you were looking at it from the outside, you'd see this, it's a V. Let's just say this is a V8 because it's what I know the most about. But within this block, there are going to be a bunch of tiny tubes and tunnels, and this allows oil and whatever coolant you're running, whether it's water or antifreeze, to run through the engine. Because engines, they have a lot of components moving very fast, doing a lot of things. It has to stay cool because a lot of that, the combustion, the explosions, and the friction of metal against metal creates a lot of heat. So you got to lubricate the engine, and you got to cool the engine. So there's going to be a lot of like tunnels and networks through the engine block that help it stay cool. And let's draw a cylinder. We're going to draw an inline cylinder here, just one straight up and down. So there's our piston. So look, here's a piston, but the piston isn't just the only thing that's part of the cylinder. The outer edges are known as the cylinder wall, and within the cylinder wall, let me draw you something. There's little ports on the side. Now, every time the piston goes down to its lowest position, right here, these little things right here will squirt out oil so that when it moves up, there's oil rubbing against the side of it so that it's nice and lubricated. And if you don't have oil, it causes friction, it'll wear down your engine parts, and that is super bad. That's why you shouldn't run your engine without oil. That's a really bad thing to do. And there's also oil ports that get into like your camshafts, your crankshaft, and all the oil sits actually in a little reservoir that's going to be sitting below the engine and below the crankshaft, which is also why it's not important to put too much oil, because your crankshaft, the apparatus to which all your pistons are spinning on, if it hits that engine, it could cause it to foam up and get into the cylinders, and getting cylinders into the actual part of oil into the part of the cylinders where the combustion is happening and not just along the sides. That's really bad. That's something you don't want to do. So the top of this cylinder is known as the cylinder head, but that's actually just not the top of it. Let's pretend, let me draw you a line. So this top part here is actually the cylinder head, and there's this line that so the cylinder head is its own separate piece of metal. Sitting between the cylinder head and the cylinder is this little thing right here. It wouldn't actually go across like this. I'm just doing this for reference. It is known as the head gasket. Like there's a little circle. It's a giant piece of sheet metal that goes like this. You lay it on top of the engine block. Then you put the cylinder head on, and then they usually use some sort of like tar or glue to hold it down. And this keeps it sealed off to make sure no air or gasoline escapes through the crack between the cylinder and the cylinder heads. So that is the basic composition of a cylinder. There's holes and stuff in it, so to allow for antifreeze or water to cool the engine and oil to lubricate the engine. And now let's talk about cylinder and engine block materials. There are several different types of ways to make an engine block. The most common that like the big companies that make millions of cars a year do is they cast their engine blocks. So there's just a giant cast, a machine pours metal into it, it presses it down and molds it into that piece of metal. Now this is cheap, it's super cheap because mold made out of sand, that's really cheap. Metal, when you buy a bunch of it, that's really cheap. But there is a disadvantage to doing that, in that when you pour that in, pockets of air could get trapped inside your engine block, and when it hardens, there's still a little hole in there, which makes it a lot weaker, and you can't throw as much abuse at it and add as much fuel and air and run as much power as you want because it's not structurally sound. Now, another way of making it is through forging. Forging, what you do is you get the engine, or you get the piece of metal in the general shape of the engine, so that they do a little bit of molding, but not enough that there could get air pockets. And then they let it cool, and then they just use a machine to heat it up. And once it's hot enough that it won't melt, but you could like bend it, they use machines to like punch the metal into the shape you want. This helps it stay stronger because it never fully turns into a liquid, and it helps prevent those air pockets. Now, the most expensive and best way, but the most people don't do it because it's way too expensive and not efficient for making a bunch of them, is a billet engine. A billet engine is where you start with a giant block of metal, and then a machine slowly grinds and wears down on it and chips out and just scratches away at the metal until it's in that piece. This means that the metal never actually does any sort of melting at all, and is the best way to make, like a giant engine with that you're going to run 2,000 horsepower out of. But once again, it's very expensive. So now moving on to the different types of materials that you can make an engine out of. There's two main ones: aluminum alloy and cast iron. Cast iron is of course cast in a mold, and it's usually like mostly iron. There's like some copper and nickel in there, and it's like the strongest material, but it's the heaviest material also, so that's the trade-off. Aluminum alloy, it's almost as strong as iron, but it has a little more give, it bends a little more. So it's lighter, you could run almost as much horsepower, but it's not quite as strong. So that is today's lesson. If I didn't clarify on something, please ask me. And I love you guys. I'll be seeing you later. Damn it, stop.